One of the things that we stated when we did a questionnaire in the beginning was that hashing itself was basically the fingerprint, right? The digital fingerprint of a file. And that file can be a picture, it can be an audio, it can be text. In the email, we have a bunch of header fields like to, from, subject, CC, BCC, right? So all these fields within the email can be hashed. The body of an email can be hashed. An attachment that's part of an email can be hashed, right? So all these can be hashed individually, or they can be hashed together, right? And the thing with hashing, if one bit changes of that file, remember bits and bytes, right? Bits and bytes. If one bit of the file changes, the entire hash value changes. And I'll show you exactly what a hash value looks like, in this, right? So the definition of a hash is basically a cryptographic hash is a one-way function of streams of data of a message digest of 128, 160, or 256 bits, depending on the hash function. And the reality is we have even up to 512, right? So if ever you see like SHA-1, SHA-256, SHA-512, the number after it is just how many bits, meaning how many zeros and ones make up the actual hash value. The way we see the hash value, which I'll show you in a second, is through hexadecimal. For every hexadecimal digit, it represents 4 bits in binary, right? So we'll get to that in a minute. So the bottom line with hashing is no two files can ever produce the same hash value unless they're identical. If the hash values are identical, that means you have the exact file. And the chance of having 2 different files matching a hash value, and in this case for MD5, and I added this statistic on purpose because MD5 is only 128 bits. 128 bits, again, 128 zeros and ones. Anyway, the chance of 2 different files having the same hash value when using the lower end of bits is 340 trillion. Right? So another way to say that is 2 to the 128th power. So if you guys hopefully recall, I don't know, math in high school or in college, depending what math you're taking, right? 2 to the whatever power, right? 2 times 2 times 2 times 2. So picture that 128 times. And that actually produces that number, 340 trillion. That's the chances of the files matching. So you can imagine if it were 160 bits, or if it was 256 bits or 512 bits, the chances are even greater than that. All right. So, and the reason that MD5 is used is because it's recognized by law enforcement, by private corporations, and the court system, right? The courts use MD5 and use hashes when in regards to data integrity, right? So that's that's part of the reason why it's so important. Any questions on that so far? Okay. So in terms of what a hash value looks like, I took one of my older slide decks, in this case, a training slide deck, and this is an MD5 output to that training slide deck. It's an older PowerPoint presentation because you can see it's PPT, right? As opposed to PPTX, right? Those are the newer formats. And even newer, it's not, it's unfair kind of say newer either because we're talking about maybe a little over 10 years, is the X format had come out. But anyway, we see 115A92, whatever, and then it ends with like F5B6. This entire alphanumeric sequence is actually a hash value, and this is hexadecimal. And hexadecimal is base 16. So what that means is I have, in regards to my available character set, I have 0 through 9, right? Number 0 through 9, and I have letters A through F, where A represents 10, B 11, C 12, D 13, E 14, and F 15. So I have 0 through 15, or another way to say that, 0 through F. Those are my character sets within hexadecimal. So that's why it's base 16. 16 digits, right? 0 through F. Any questions on that?
Professor, I have no idea what you're talking about. Like, I'm looking at you, I'm looking at the screen, and it just doesn't sound English.
No, all good, all good. Okay, how about this? You know what base 10 is, right? Base 10 is 0 through 9, correct? That's the number system that we all use, right? We're familiar with. That's base 10, 0 through 9.
Mm-hmm.
Base 2 is binary. Base 2, when I remember I was talking about bits, that's base 2. Zeros and ones. There's only 2 options, right? Base 2, 0 and 1. But base 10, you got 10 options, 0 through 9. So when you hear me say base 16, or you hear me say hexadecimal, it's the same exact thing. What I'm saying is you have 16 options, a 16 alphanumeric character set, 0 through 9, right? That's 10.
Okay.
And then you got A through F. That's an additional 6, right? Because we're counting the 0, right? So 0 through F is all our available characters. So if you look through this sequence, right? If we look through the sequence here, you see A, B, C, F, E. I don't see a D here, but the bottom line is the only letters we will see is A through F. We're not going to see G. We're not going to see H. We're not going to see Z, right? Because that's not what, base 16 is. If I really want to confuse you guys, we can talk about base 64, but we ain't going there, all right? That's 64, possibilities. But for our purposes, for right now anyway, we only need to be concerned with base 2, base 10, and base 16.
So, Professor, base 10 and base 2 wouldn't have any A through F, like any letter at all. It would just have, like, base 2 would have 0 and 1, and base 10 would have 0 through 9. And this
exactly.
would be a hexadecimal, right?
Correct.
Okay.
Base 16, exactly. Base 16 right here is hexadecimal, and that's 0 through F. So that's why when you look at these number sequences here, right, alphanumeric, right, you're only going to see letters in regards to A through F, and you're only going to see numbers in regards of 0 through 9. That's it. Right. So if you counted these number sequences up, right, we counted how many characters this is. This is actually 32 characters, 32 hexadecimal. It's another way to say this. Down here, I have 32 hexadecimal characters. 32, right? That's what MD5 is. Every hexadecimal character represents 4 digits in binary. So if we did the math, 32 times 4 is 128 bits. So that's how we got MD5 is 128 bits, meaning 128 zeros and ones. But it's think of what type of mind you have to be able to try to interpret or to look at 128 zeros and ones and try to make sense of it, right? Very difficult to do. But it's easier for us to make sense of 32 hexadecimal digits, right? It's easier. I can look at this 115A and then look at the end, F5B6, and be like, okay, you know what? I can compare, if I have to compare 2 files, I think I can compare 2 files with 32 digits. I can do that on my own, or maybe I can do it through a given application.
Can you repeat can you repeat what you said, that every hexadecimal represents what?
Yeah, 4 digits in binary. So in other words, if I had F or A or B or even a 2 or a 5, it doesn't matter what it is. One hexadecimal digit is 4 bits in binary. So as we're going to see, to represent 0 in binary is actually 4 zeros. To represent 1 in binary is 0001, right? 3 zeros and then a 1. Right? Again, this is not for you guys to do any calculations or whatever. It's just only for you guys to see it, to be like, oh yeah, I kind of get it. That's fine. All right. But what I want you to get with this is that when we're looking at 32 hexadecimal digits, that you're able to compare 2 sets of digits. All right. So anyway, MD5, and also to be able to calculate how many bits, right? So if MD5 is 32 hexadecimal digits, the way to get the binary to that, how many bits is that? Actually, you multiply by 4. 32 times 4, that's what gives it 128.
You multiply by 4 always?
Always. always. If this was, for example, here, we got SHA-256, right? SHA-256, that means 256 zeros and ones, right? 256 bits. So 256 zeros and ones. But another way to say that is 64 hexadecimal digits. If we multiply 64 times 4, that's what gives us the 256. Now, hopefully it makes sense as we go along when we do the practical.
156, correct?
I'm sorry?
156, 64 times 4 is?
64 times 4 is 256. Okay, so in other elements in which hashing is used, right? I was talking about in relation to fingerprinting, right? You know, digital fingerprint, right? We can check if a file is in fact, you know, legit or came from a particular place by doing, by running a hash over the file and determining what the hash value is. Well, hashing also takes place in other areas. So for example, hashing is also used in what's known as a CRC, a cyclic redundancy check. And all this is this is done behind the scenes, and we just don't realize it. But when you copy a file, for example, from one location to another location, the computer internally normally performs a CRC check to make sure that when the file gets copied over, that it is in fact copied intact. That, you know, like if you do like a copy and verify, for example, if you do some sort of verification, that's what it's doing. It's running a hash over the file to determine if the file has completed, you know, has been completed successfully. So if ever you see where you get a message saying copied successfully, or, you know, file copied or whatever, that's because a hash value has been run over it and is determining the hashes match. That means the destination is the same as the source, right? It's intact. If you guys ever use any peer-to-peer networks, right? Like torrents, or if you ever used LimeWire or BearShare, maybe I'm just dating myself, you know, with this, but torrents, for example, you know, people that are downloading like music or movies, right? You didn't hear it from me that you would, or you don't have to let me know that you're downloading illegal music, you know, music or movies for that matter. But these torrents, you know, or websites, that's what they're doing. They'll give you what the hash value is on their website. And by them giving you what the hash value is, you want to ensure that when you download the file, that the hash values match. So that's the reason why they give you the hash value. And I'll show you today how to go about determining the hash value of a file. And then when you download it, you can verify that the files match. If they match, you know, you're good. You know, you got the same exact copy that was on that website. If the hash values are different, something went wrong, or another file may have attached itself as you were downloading it, and that can be malicious. So that's why they say be careful where you download your files from, or verify that the files you downloaded are in fact the same. And you do that by looking at the hash value of the file. And a lot of these websites, what they do, if you hover over a file, or even next to it, you'll see the hash value of a file. Maybe you never realized it before, and hopefully after today you'll realize that they'll give you what the MD5 hash value of that file is on their website. And then as you download it, you can verify the hash value by running a tool and then making sure that the files do in fact match, at least the hash values themselves match. How about the antivirus programs that you guys, hopefully all of you have antivirus programs. Antivirus programs use hashes also. That's how they know you have, you know, a virus on your system, because it determines what the hash value is of that file in memory, or that file on your hard disk, or that file on your thumb drive. And it matches the signature database to that antivirus system. And if the hash values match, it's the same. So another way to say signatures, right? If you see like, you know, antivirus signatures or anti-malware signatures, it's the same thing. We're actually referencing the hash value. So another way to say hash value would be signatures. Any questions on that so far? Okay. Hash sets can be created based on an operating system. So let's say if I'm a forensic, you know, analyst, and I need to analyze an entire hard drive, there's no sense for me to analyze, let's say the operating system, let's say Windows 10. I don't have to analyze Windows 10 if I know those files are legit. And the way I determine that those files are legit is I download a already made hash set of Microsoft Windows 10 operating system, and I filter it to exclude all the operating system files. Because the only files that I'm concerned about are the files that are not, actually the files that are unique to, that are either user generated or that have been there, that have been placed on the hard disk that's not related to the operating system itself. So I can exclude certain hash sets, right? So I can use filters to either include or exclude specific data sets. Any questions on that? Okay. Same goes for patches or updates. How does your computer know an update is required or something needs to be patched? Or you have an application, the application says, oh, you need to download the latest update. And even on our phones, we'll see that all the time, right? If for those of you who have iPhones, anyway, I have an iPhone. An iPhone will have that, oh, there's an update, iOS update. You have to update, or you can update at night or whatever. It gives you a choice, right? How it knows you need to update? Well, it runs a hash value. It takes a hash value of of what your current installation is, right? What's your currently installed operating system. It takes the hash value of that versus the hash value of the latest update. If the hash values are different, you need to update. If the hash values are the same, you don't need to update, right? So let's say if you did and you're checking to make sure that, oh, I want to make sure if I have the latest update. Well, the reason your computer knows it has the latest update is because it performs a hash check. It checks if the hash values match, no update required. If the hash values are different, update required. Any questions on that? Okay, so some of the shortcomings of hash values is that the smallest change will alter a file's hash value. And so when I say the smallest change, I'm talking about a bit. Remember we said a character, like 8 bits to a byte, right? A character is a byte. So the letter T, for example, this letter T in the is 1 byte, but the word the is 3 bytes. So if I was just hashing the, let's say I just hashed that, and let's say I changed the uppercase T to a lowercase t, that's actually a different value, right? To a computer, uppercase and lowercase are two different letters. So the hash value would change completely, and I'm going to show you what I mean by changing completely. So let's say, just for argument's sake, that the hash value originally started out as, A123. If we change the uppercase T to lowercase t, it's now something like 984. Like that's how it begins. It's totally different. It's not like A becomes B, 2 becomes 3. It's not, it doesn't make any sense whatsoever. It's totally randomized. So making the smallest change to a file may not entirely change the entire content of the file. It changes the hash value completely. All it proves to you is that the file was changed. The file was altered in some form or fashion. And keep in mind that we're talking about bytes, right? We're talking about characters. But when we start getting a little more advanced, we can begin to translate this to pixels, right? In terms of what a graphic does, right? A pixel, one little pixel can also be represented as a byte, right? So now, we get into, graphics that the slightest change to a graphic alters, it can alter the picture completely, or the picture can look exactly the same, and you've made some alterations to the picture, but you can prove alterations were made because the hash values don't match, right? The smallest change to the file changes the hash value completely. And I'll show you exactly what that looks like. Any questions on that?
No.
Okay, so the same goes for this. Hash is a one-way function. There's no reverse engineering a hash. You cannot determine what exactly was changed on a given document, or what exactly was changed on an executable file, or what exactly was changed in a picture or anything else. There's no reverse engineering that. So not through a hash value. There are other ways to determine differences in files, right? In Microsoft Office, for example, there's a compare documents feature. if we're dealing with text documents, there are compare functions available for text documents as well as for any Microsoft related type of document. You do now have compare functions where it gives you what the original file is, what the changes were, and you can even output a file of only those changes. You know, so there are ways to do that, but you know, these are just, again, I'm just trying to explain, you know, different shortcomings when it comes to hash values. The other is, let's say we had a hash value of a Word document, and that Word document was converted to a PDF document, right, to Adobe Acrobat file. The content of those two documents are exactly the same, right? So let's assume that this Word document was my resume. I originally had a Word document, a resume, in which I had a hash value for. And then I have a PDF document that I created. Same exact content. And then when I do the hash value for that PDF document is totally different. The Word document and the PDF document have two different hash values, but the content's exactly the same. So this is one of the issues with hashing. And when, let's say, an investigator is looking for a particular file, I may only have the hash value for the Word document, not for the PDF that was created, you know, behind it. So now I have to go into a different type of realm, what's known as a near duplicate. And near duplicates can also be considered fuzzy hashing. So if you ever hear the term fuzzy hashing, which I have it here, fuzzy hashing can be considered near duplicate. What that means is I can take through one utility, for example, is SSD. I can take a third-party tool like SSD, and what it does, instead of hashing the entire document, it hashes portions of that document. So let's say I take that one document and I split it up into 8 parts. So I'm hashing 8 parts of that document. So for 8 parts of the document, I take 8 parts of that Word document, and I take 8 parts of that PDF document. There are going to be differences in the document because keep in mind, right, a PDF has different formatting than a Word document. A PDF document technically is created by Adobe Acrobat. A Word document is technically created by Microsoft Word. So the formatting of the document is going to be different, right? How you italicize, you know, wording, how you do paragraph indents, how you do set the pages, the print areas, what you have embedded and the coding behind all that is what's different. But the content, like I said, is going to be the same. So I may take my resume, that's a Word document in PDF, and it might come up with a similarity of 80%. That might be good enough to say, you know what, I think I got the same document. Because what's different about these documents, that 20% could be the formatting, the stuff that's specific to PDFs and the stuff that's unique to a Word document. That's the differences, right? So, and I can change that, you know, those similarities. You know, I can say, you know what, I want just something maybe 20%. I'm looking for 20% similarity because maybe what I need is the signature portion of it, right? Who it was from, right? So I can change that. So literally I can change it anywhere between 0 to 100%. And so those are considered near duplicates. Any questions on that? Okay, and lastly, we have what are known as rainbow tables. And I actually have rainbows, that's a mistake. Yeah, that's a typo, I gotta change that. It's a rainbow table. And what rainbow tables are, and we'll have a lab in this too, by the way. Rainbow tables is when you have the hash value and not the actual, they use more for like passwords, right? So let's say, for example, I have a database of all the most common passwords. And what I did was I hashed all the common passwords. And so if I have the hash value of a password, I put in the hash value inside a rainbow table, and what it produces or what it outputs is the password. It outputs the word for that rainbow table. And I'll show you how that works too.
So it means when you didn't finish your sentence. You said when you have the hash value and not the actual.
I thought I finished it.
You did, but I'm trying to write it down in a way.
No, I got you. Yeah. So the rainbow table is when you have the hash value, and what you get outputted is the password. Because keep in mind, normally what we're always trying to do is get the hash value of a given word, of a given file, of a given picture, audio, or whatever. We're always trying to get the hash value for that, right? To check against something else. You know, if we're comparing two files, we want to make sure the two files are the same. So we compare both files' hash values just to determine whether they're the same. Well,
But it's used for passwords, right?
exactly. What a rainbow table is primarily used for is when you have the hash value, but you want what the password is. You want to know what the password is. And the reason rainbow tables or hash values are important is because when computers communicate with each other, when you're logging in to let's say to a Windows server, or when you log into a network, what gets passed is not the word that you type. What gets passed is the hash value of your password. So technically, your password never gets sent. It never gets sent over as plain text. It gets sent over as a hash value. So an adversary or a hacker will use how these systems work. They know how they work behind the scenes, and they know the hash value gets passed. So what it does is they would capture the hash value. And now all they have to do is put your hash inside a rainbow table to be able to produce the password. So this is an example. Crackstation.net is a rainbow table in which you will put in the hash value and it would tell you, it will spit out what the word is, provided it's in its database.
I have
Any
a
questions?
question.
Yes.
With binary, you know how you can I'm sorry, you can translate the numbers into like actual numbers. So like the 0 and the 1s, if you label a certain way, you can say, okay, that's a 1, this is a 2. Does that also work in hash? Can you, how it's written out, can you convert that into like an actual word without the converter?
No, because the converter itself is some special algorithm that each hash value uses. So like MD5 is short for Message Digest version 5.
Gotcha.
SHA-1 is secure hash algorithm. There's also advanced encryption algorithm, AES. All these different types of algorithms that are used. So based on the algorithm, basically determines the of doing the conversions for this. So you and I cannot do this manually. So it has to be done through a computer or through a program.
Okay, gotcha.
I just want to load up these. All right, so now we'll go over the practical lab. Let me just get all the tools ready for you guys here, so that way we're good. Okay. So again, just to show you guys how this works. This is a MD5 hash generator. This is, you can do online, not a big deal. And it's also part of the lab too. And this is going to be important, for your assignment. But again, I just want to show you. You go to MD5. Again, just let me do it first so I can show you guys. And then you guys feel free, to go crazy with it, after the class, or, whenever you got time. So let's say, for example, I'm going to put in the word password. And I'm going to say, okay, generate. And what it does here is it generated 5F4D. You guys can see that, right? It might be a little too small right now. Hold on a second. Let me just make me throw it in this. All right. So the word password, right? So the hash value for password, again, without the quotes, is this. It's 5F4DCC, whatever, all the way at the end. So when you're looking at a hash value, the thing that your eyes should focus on, and this is what I do, is good practice. Look at the first 4, and look at the last 4. So this is why I say this. I'm going to generate password with an uppercase P. And I'm gonna generate. Look how different. This is with an uppercase P. You see this? DC 64, and then it ends in 3964. Very obvious, right? Very different. And all I did was, it's the same word, right? But just one is lowercase, the other is uppercase. So completely different. What if I did password with a space at the end? I did password with a space at the end, lowercase password with a space at the end. That space is also considered a character, right? It's also a byte. This is password with space at the end of it. So that's why it's important that when you're producing hash values for yourself, especially working with text, you want to make sure there are no trailing spaces, right? Nothing at the end and no preceding spaces at that, right? You don't want to no space in the beginning, no space in the beginning, no space at the end. So you see how completely different? 9F96, 1A75. Any questions on this? Okay.
Nope.
All right, cool. So again, very simple, right? So let's say if I asked you, what is the hash value to malware? Malware. The hash value, you literally type it in, click on generate, and the hash value gets produced. It's literally that simple. Right? So malware equals this. It starts with F3, F0, and ends in B3, A6. That never changed. That would never change ever. If we're dealing with, this is MD5, right? MD5. MD5 hash will never be different. Malware will always produce this result, this one-way function. So the same way text produces a one-way function like this, if you create a file and that file is run through a hash program, it would always produce the same exact hash value, no matter what. That same file, that is. If someone else produces a file with the same content, it'll be different. But their file would be considered the original file. Any other questions on that in particular?
Are we always using that website to find out the hash?
You can from MD5, but that's not your only recourse. So for example, this is one of the tools that we're going to be using in this class is Hash My Files. Just out of curiosity, are you guys, anyone using Mac?
Yeah.
Yes.
Mm-hmm.
Okay, and you guys using Windows 2, correct? Whoever's a Windows user, I just want to make sure.
What?
Okay. All right, I'll show you both ways either way. Within the practical lab itself, did I just let me just make sure.
So quick question.
Yep.
Sorry, in the meantime. That means every hash value is unique. Every hash value is unique to every file.
Correct.
Interesting. Okay.
Right. It's only the same if this is the same exact file. That's the only time it's the same.
Okay. Cool.
All right. So if you're using a Mac, you would use actually this is an older version. All right, no big deal. I think I updated it for you guys.
No.
Yeah, I did here. So if using a Mac, download iHash. So on a Mac, you will use this, iHash. And iHash has, it says file here, file, and then here you have text. So I can type in text. Remember we said password? It's SHA-256. Let me change this to MD5. Hold on a second. So you see here, you got MD2, MD4, MD5, SHA-1, SHA-224, SHA-256. So let me just change to MD5 and the word password. I'm gonna copy this. And then let's go back to our, oh, too bad I didn't, oh, actually, can I, let me see if I can just undo this. Okay, cool. All right, so I just did password. Look at that, it matched. You guys see that?
Mm-hmm.
Remember, I did this with MD5 generator, and I did this with iHash, you know, for the Mac. Same exact password. Same thing, if I did a space, let me just copy this. I copy that. And there was one of these with the space. Let me see which one it was.
The last one.
Yeah, the last one, yeah, exactly. Yeah, the one below it, exactly. Right, because that one goes to the uppercase P. Yep. So you see, so it's exactly the same. So it doesn't matter what I use, it worked. So now let's say that word password, right? I'm gonna go to the rainbow table to see the rainbow table produces it. This is my rainbow table, crack station.
So does that mean we're gonna see the hash value? We're gonna see the characters instead?
Exactly, right, exactly.
It's like reverse.
Exactly. Yes, exactly, the reverse.
Oh, shit.
That's crazy.
I hate these little, no, you got it.
No, I'm about to use this information for other purposes.
So look, you have the hash value here. You put in, you know, I'm not a robot, and then you click on crack hashes. And look at that. Password.
Okay.
Wow.
Okay.
Yep, that's how that works.
Professor, a question. How would you get the hash value though?
Oh, well, we just did. Either through, if you're using a Mac, you're going to use iHash, or MD5 generator is another option. The other option, which I was going to show you guys, is if I create a document, a text document. If I'm using Windows, I create a text document. And let's say in this text document, I type the word password also. No space, no nothing, right? Close out, save it. I drag and drop that text document onto this. It produces a hash value. You can tell I'm gonna copy the MD5 hash value here. It's actually the same. I'm gonna put it up on top here. I'll put it above this actually. The same. 5F4D, and it ends in CF99. You see what I mean? So these are 3 ways I've shown you how to do it, right? I can create a text file, not a Word document, right? Right now, if I created a Word document, which I don't think I have Word on this. Yeah, this is one of my text box.
But if you created a Word document, it would be the hash value of the Word document and not the Word itself, right?
Exactly. Remember, the Word document has those extra features, right? Those extra features that are required to produce Word documents, right? In particular, extra functioning and stuff, right? Whereas a text document is a plain text. There's no header information. There's no special characters in it. There's nothing. So this actually matches what we went to a website for, MD5 hash generator. This hash my files you can install. This is for free. This is open. It's considered open source. We go to the website, and just in case so you guys know, we can go to the website, and that's Neosoft is the website for this. You click on this. I have the link on there. Within Blackboard, it'll ask you to click it again. So you just click it again, and this is hash my files. And all this is considered open source, right? So it's free to download. You scroll all the way down. It gives you, examples how to use it or whatever. And you click on download hash my files. Like, it's that simple.
Oh.
Then once you download, you save it. And then you can double click on it to execute it or whatever. Normally you double click, you would have to like unzip it. A lot of the files, if you're using Word, a Mac or whatever. I don't think this works for a Mac, but I'll show you how to unzip it regardless. See, if I have zip file, I right click and then I choose either 7-zip or archive utility, and then what it does, it expands it for me into 3 files. And now I can execute the executable file, hash my files. And the hash my files is actually this. This is hash my files. So again, this is my Windows box, right? To show you. All right, any questions on that so far? Okay, fairly straightforward, right? Okay, so the other practical example is to show you a robo hash. Like, what's that? So robo hash is another way to generate uniqueness in something, right? We use text, or in our case, P5 to represent uniqueness, right? That hash value represented the uniqueness. This is something where, let's say that same password, it gets represented as a robot. So for example, the word password, just straight up password, lowercase. Because that's a password, that's what the robot, let me make sure. Put in my name. Yeah. So the word password would always generate this robot here. This robot you see. So this robot here will always be generated by the word password, no matter what. And it tells you down here, what it is. So again, this is just about uniqueness, right? So the cool thing, what I normally do in the lesson anyway, in the practical, is I ask you guys to put in your name to see what type of robot your name represents, the uniqueness of your name, right? And this is my name lowercase, right? Looks very nerdy, right? If I did an uppercase A, I think this was kind of cool, right? So anyway, this is what my name will always generate, no matter what, in terms of this robot. This is the uniqueness of this robot. Again, it's just another way to look at it, right? The way to look at uniqueness. Instead of looking at it from in terms of a hash value, we're looking at it now in terms of a robot, some sort of graphic that's representative, of this. If I did Abraham with a space at the end, generate. Was there any difference on that? No, I don't think this takes the spaces. Let's say I'm gonna uppercase the M at the end. Is different. So it doesn't allow the spacing at the end, but just the name itself. All right, any questions on that? On the uniqueness? Again, just another way to represent.
I have a little question. When
Sure.
I start this practice, I can do my name with the first letter uppercase or whatever I want.
Yes. Yes. Yep, exactly. So let's see what else I have in the practical here. Jesus Christ. Oh, yeah, I did have it there. All right, so again, in the practical, I have what the purpose is, what's the background, the resources that are needed. The step files, I just went through it. Literally create a file, and then it's a step-by-step. Create a file, type hash name 1. Again, this is specific to hash name 1, just to show you what it looks like. Inside the text file, you can put in your first name. The second file, these are just steps to follow. Nothing, you're not graded on this in any way. It's just to get you exposure to, okay, I'm gonna open up a text document. I'm gonna put in my name, I'm gonna save it. I might drag and drop it to hash my files. If I don't want to use hash my files, right, you can use the MD5 hash generator. Just type the name there, or type the word that we need to hash, an MD5 generator. If you have a Mac, you're gonna use the iHash, right? You're gonna download this. iHash is free, by the way. Or this, you don't pay for anything. This is free. You download iHash, and you're gonna click on the text, and then type in, your name, and that's my hash value for my name. I can click on copy, and now I can paste that somewhere else. If it's a file, I can literally just drag and drop a file. Let's say, let me just take another file. I'm going to take this file, my practical lab 1 file, drag and drop it. And there you go. That's the hash value for the file. So that hash value will always be the same unless someone changes or alters the file. So I literally just drag and drop it. It's that easy. And same thing, if you had a Windows machine and you were using hash my files, literally dragging and dropping. That's how you get all the hash values. And then if you get a file that matches, let me rename this. Let's call it name. If you get files that match, you're gonna see, in this case, I don't know if you guys can tell that the 2 are highlighted.
Mm-hmm.
If you can see that, like the pink highlight, whatever this color is,
Mm-hmm.
you can see it tells you right off the bat that it matches, right? And you can, you don't have to be, oh my God, look at the first 4 and then look at the last 4, like I told you should do, right? You just do that and you knock it out.
I have a question.
Sure.
With regards to like the type of hashes, like the MD5 and the SHA-256, what's the difference between them and when should we use each different one?
Yo, why you ask me these questions? No, it's a good question. So normally, like what happens is MD5 is like the standard, right? That's the standard that most places will use. They will, like if it's a small environment, like for example, if it's a company, if it's law enforcement, if the courts or whatever, they would always want MD5s. So almost everything has an MD5 no matter what attached to it. But in addition to MD5, what a lot of companies are doing is they're making SHA-256 the new standard. So you see a lot of SHA-256. Like when we talk about malware and viruses and stuff like that, these websites now produce SHA-256 as the norm.
Professor?
Yes.
Could you comment on why law enforcement still uses MD5 since it's been broken?
Yeah, because what it is, MD5, see, although although it's broken, it breaks in a very controlled environment. And when we're dealing with, the sampling that we're dealing with is we're dealing with a thumb drive, we're dealing with a hard drive, or we're dealing with an entire company's network, and the possible sample of all the possibilities that a company has in terms of storage wouldn't necessarily exceed that 340 trillion number. So that's why MD5 is still used, and MD5 is used in relation to software, to virus signatures, to all this stuff. But part of why they also use SHA-256 nowadays is to accommodate or to just in case that there are collisions, right? That's another way to call them collisions, when you have 2 different files that actually have a hash value that match. To compensate for any type of collisions, they use stronger algorithms such as SHA-256. So that's why MD5 is still used to date, because in terms of the sampling that's used, it's still good enough.
Okay, that makes sense. Thank you.
Yeah, you got it. All right, so I think we went over the entire practical lab. So now I want to go over the assignment so that way I can show you guys how this works. So there are only 5 questions like I told you before, right? So let me just show you. You guys can see that, or you need it a little larger?
A little larger.
Yeah, a little larger.
Okay, cool. You guys can see that, right?
Yep.
Better? Okay.
Yeah.
Okay, so keep in mind, you got a couple attempts with this, right? So question 1, what is the MD5 hash value of John Jay College without quotes? Very easy, right?
Mm-hmm.
Literally, I ain't gonna show you, but obviously you copy John Jay College, or you type it in MD5 hash generator, or you type it in iHash, or you open up or you install hash my files, throw it in a text document, and drag and drop it, right? Those are your three ways of getting what the hash value is. And all you're doing here, you're literally just copying whatever that hash value is, right? So in my case, right, this isn't a hash value for it, obviously, but I'm just going to copy, and then I'm going to paste it in here. Right, I'm going to just click on save my answer. I'm going next. Why are hash values different from hash name 1 and hash name 2, even though the name is exactly the same? Now, this hash name 1 and hash name 2 is in relation to the practical lab. Right? If you guys went to the practical lab, you'll see that actually the files that you named, you actually named them hash name 1 and hash name 2. Did I have this open? Yeah. So again, this is why I say this is the hash, this is the practical lab, but as you can see, I tell you, prompt, save this one as hash name 2 and save the top one as hash name 1. So why are they different, right? Again, looking through the document, you can tell why they're different. Let me go back to my lab here. So, they're not the same because to a computer, uppercase and lowercase letters contain different values. The hash values are not different. They are the same. They are the same because it's case sensitive. They are the same because to the computer, uppercase and lowercase letters contain the same values. Right? You guys can figure that out based on what we went over, correct?
Mm-hmm.
Yep.
Now, question 3. Why are the hash values from hash name 1 and the hash generator website exactly the same? Because hash name 1 is a plain text file with no file header. Because hash generator copies the file header. Because hash name 1 is a Word document with a set file header. They aren't the same. Again, based on what we went over, you should be able to answer that question. Question 4. You can have 2 different documents, Microsoft Word that ends in docx and Adobe Acrobat that ends in .pdf with exactly the same content. Why would their hashes be different? Because the content is really different, because their file extensions are different. One is docx and the other is PDF. Because each of these contain their own unique file headers and are coded specific to their applications. Because each of these contain their own unique file headers and are coded specific to the given operating systems. Again, based on what we went over, you should be able to answer that question too. And guess what? You get it wrong the first time, you get it right the second time around, right? Question 5. A near duplicate or a fuzzy hash are basically the same in that they both break down a file conducting smaller comparative hashes to determine if the contents of a file has similarities with another file. It can even produce a percentage of similarity. True or false? Right. So based on what we went over, you should be able to answer that question. And like I said before, you get it wrong the first time. When you take it again, you get it right the second go around. Any questions on this? So this is why I say you go over the practical lab first, and you let me go over the practical lab with you guys. So that way, at least I'll walk you through it. Then you can do it on your own. And then when you come to this, it should be a no-brainer. You should be able to, without question, be able to get what the MD5 hash value is. And now from this point forward, you know how to get the MD5 hash value, right? You'll know how to get from a text document, from straight up text, or even dragging and dropping any document, whether that document is an image, or audio file, or whatever, to produce what that hash value is. All right, any questions?
Yes, I think go over again to the three ways to find your hash.
Yes. So the first one was through the MD5 hash generator, right? The website, MD5 hash generator. You type in whatever word, in our case, we just typed in password, click on generate. That's one way to do it, right? That's hash value. Mm-hmm. The other way was if you're using a Mac, iHash, you click on text, and then you type whatever word you want. And then it automatically puts what the hash value is, and you click on copy, and now you can paste it somewhere. Right, that's the second way. And if you're using Windows, we can create, if you right click, do a new text document, double click inside a document, type in this case, password, no space, no nothing, no enter, X, save, and now we drag and drop that document, and we have what the hash value is. So those are the three ways: one in a Windows environment, one in a Mac environment, and another in on the web where it's independent of Mac or Windows.
I see. All right, cool.
And remember, CrackStation is a rainbow table, right? It does the opposite. You put in the hash value, and it gives you what the word is.
Right, I see. Gotcha.
Okay, so anyway, you guys should be good now in regards to being able to be practical, to be able to do the assignment, and to be able to understand what a hash value is, how it looks like, what base it uses, and the fact that we have differences, right? MD5, SHA-1, SHA-256, and all that stuff, and what that 256, means, right? 256 bits.